everyone for joining this presentation of Rhino inside Revit for optimizing the Rhino to Revit workflow. I'll just do a quick introduction to the tool itself, let you know what it is and how it works, show you how to get it set up, and then do a little overview of the interface. And then I'll go through some workflow examples that have been created by McNeel and some that I've created myself that I think really kind of showcase how powerful of a tool it is in and of itself, and then what it can enable designers to do in the future. And then we'll wrap it up with a Q&A at the end. Okay, so what is Rhino inside Revit? It's an add-in for Revit, just like many other add-ins that you may have installed with Revit, such as V-Ray, Enscape, ID8, or PyRevit. And really what McNeel has done with Rhino 7, which additionally was silently released this week, so you can go ahead and grab that. But with Rhino 7, what they did was rebuild it so that it was a little bit leaner and it could exist, it could run within the memory space of another .NET application. In this case, it's running as an add-in or a plugin within Revit. So this is incredibly powerful because it provides the full access to Rhino's geometry engine and Grasshopper, and then all of the different plugins and features that come with that, in addition to the new features that are in Rhino 7. Some of the new features include sub-D modeling, quad remesh, clash detection, and many more. Additionally, through Rhino inside Revit, you get access to all of the plugins that are available at foodforrhino.com, including Kangaroo, Weaverbird, all of these wonderful plugins created by the community or those that also work at McNeel. So now, really, what this tool does is it expands your tool set incredibly. So even your plugins have plugins. So it's a really powerful tool, and it allows you to control your Revit elements in whichever way that you choose to be the best for your workflow. So I think that this is a tool that really enables designers and opens up the possibilities. Okay, and what it can do within Revit is alleviate a lot of the import and export pain points that many people experience, because the Rhino and Revit APIs are working. Are accessing each other directly. So there aren't the same sort of issues when importing or exporting, where you're relying on the quality of how Revit exports IFC or anything like that. You're directly accessing the elements within Revit and bringing them over into Rhino or Grasshopper, and Rhino inside Revit is the bridge that creates that connection and allows this to be possible. So you can modify or create geometry and also modify parameters. So it's a very powerful tool. So let's proceed here to the next slide. Okay, so to get set up and installed, first of all, it is compatible with Revit 2017 up to 2021, and I'm sure it will continue to the next versions of Revit as well. You'll need to have Rhino 7 installed. If you have a seat of Rhino 6 right now, then you have access to a free trial of the Rhino 7 beta, or the work in progress. So you'll just need to get that installed. And then Rhino inside Revit is an open source beta add-in, so you can download that right from the link shown right here. And I'll just click on that to show you where to go. And this is a great resource, great page. It has a lot of great documentation on getting started, wonderful guides in here to to help you learn how to use this tool, just to get started, and then community reference, a lot of great material in here that that you'll find very helpful in getting started. I certainly know that I did. So this will be a great place to start once you're set on installation. Okay, and then once you have it installed, you'll be able to initiate or open the plugin through the add-ins tab, just like any other add-in, and a new tab will appear within Revit. And as you can see up at the top, these are the different options you have. You can open up a Rhino window. You can import 3DMs directly into Revit. You can open up the Python window for Rhino, or work directly with the Grasshopper canvas with Grasshopper. Most of the connection between Revit and Rhino will be through Grasshopper, but you can certainly work within the Rhino model space and have all of the data transfer through to Revit through Grasshopper. Okay, so there are, I see it as three different main things that you can do with this tool. You can access and edit Revit model information. You can create new Revit models from Rhino and Grasshopper, and this can be generated either within the Rhino model space or directly as Grasshopper objects. You can also create Rhino geometry from these Revit model elements. So you can create the geometry, you can pull in the categories and types, so that you can then create and assign layers and sublayers and materials within Rhino. This may be a good workflow if you have like a rendering program installed for Rhino, such as V-Ray for Rhino, but most of the project is in Revit, but you want to be able to visualize something at the completion of a certain stage of the project, and you would be able to do that with Rhino inside Revit by transferring all of the elements over to Rhino and then rendering from there. Okay, so without any further delay, let me just switch over to Revit here. So I have a familiar model open here. This is the advanced sample project provided by Autodesk. So I've already started the Rhino inside Revit, and again, like I said, that's from the add-ins tab, and you just click this button here, and this is the tab that appears, and these are all of the different options here. Something I didn't mention is the Grasshopper player, which is new in Rhino 7 and is available through Rhino inside Revit here, and this works very similar to the Dynamo player, where you can load scripts and have it run without having to actually open the window and run the script in that way. So this is a very nice and easy way for any users in an office that are not very familiar with this sort of hypergraph scripting, but may want to use the tool. So you can just click on that, open up a Grasshopper definition, and it'll run. It'll run based on what is in the file, or just whatever the script determines. So let's see here. I'll open up Grasshopper, and the first window I have here is just all of the components from Rhino inside Revit, all displayed out here. So this is a very large tool set, and it's really exciting to see all of this functionality. You've got your primitives down here, which is these will be available in the parameters tab here, down here in Revit primitives. And so this would allow you to reference or pass through any of the Revit elements from the model. You also have many options to build components. You can build beams, floors, columns, roofs, and railings, very similarly to how they could be created with Dynamo, where you need to provide a closed planar curve or a planar curve, but very powerful tools there. There's also a component here to add adaptive components. So those are very powerful. So you can add all of these components in there. And I'm not going to go through each one of these. That would be a much longer webinar, but I just wanted to kind of display all of the work that's been done here to enable all of this functionality. So a lot of great stuff. Some of these new material components here allow for a lot of flexibility for creating new materials or modifying materials. Something I've liked to experiment with here is creating parameters within an adaptive component family and then modifying those parameters down to the instance so that you can have a lot of variety within families and a lot of control over your BIM objects. So that's just a quick introduction here. Let's get started with the first workflow, which is going to be what I've called a Revit to Grasshopper round trip. So what I'm doing down here, I'm taking the primitive of an edge. So for this exercise, I just want to, what I want to do is reference some Revit objects, and in this case, I'm going to be referencing Revit edges to then create a surface in Grasshopper, and then I will push that surface back into Revit as a roof. So it'll be properly categorized. It's not going to come in as just a generic model. There's a lot of power here. So I'm just going to unlock that solver. And I've already referenced these, but I'll just go ahead and show you how this is done. I'll right click that primitive component, set one edge, and then I'm just going to set this that edge along that roof there. And then I'm going to create, I will reference another edge. Let's see, I'll take this edge up along this parapet right here. All right, I think I got the right one, but let me just make sure. I think I moved slightly. Okay, there we go. So I have these two edges now selected. Let me zoom out a bit. And I'm feeding that now into the script, and I'm modifying it through Grasshopper components. And you can see these barriers that I've created just to indicate what I'm doing that's just purely Grasshopper, what requires the Rhino.Inside.Revit component, just because there could be workflows where you have where you're just working in Rhino and Grasshopper, and that's all you need. But to run any of these Rhino.Inside.Revit components, it needs to be run through Revit as shown here. So what I'm doing here is, I guess I've got this to flip the two in case they come in backwards, but let me just see what I've created here. Okay, right, so I've, right now they're inverted when I loft them, so I'll just flip one of these around and it should resolve that nicely. So now you can see the preview as very similarly to how it would show within the Rhino model space, but it's showing here within the Revit space. So that's very nice. I'll just turn that back off, and then I'll go forward here to see how we can bring that back into Revit as a roof object. So we cross the barrier again here, and we're back into using Rhino.Inside.Revit components. And what I'm using here is the Add Geometry Direct Shape component. And this can be found right in the Revit tab under Direct Shapes right there. So I'll go ahead and activate that component. And as you can see, it's now created that roof within Revit. If I select it, you can see that it's come in on the roof category. Something additional that I can do here is modify a parameter. So in this case, I have a mark parameter that I'm just going to change the value from being blank to a mark test. So I'll just go ahead and activate this. Well, first I'll show you which component it is. It is the set element parameter. So what I need to feed in is the element that I want to modify, the parameter name or the parameter key that I want to change, and then the new value I want it to have. And again, this is under the Revit tab under Elements, and you can see right where it is there. So I'll just go ahead and click that and activate it. And so it should have changed that the mark parameter for that newly created roof as mark test. And I can confirm that by going into the Revit model here, selecting, and as you can see, I've got mark test right there. So that's a nice little proof of concept as to how this works. It's a very simple change of parameter, but it can be any parameter for any object within Revit, and it doesn't need to be one that was created through Rhino inside Revit. It can be any element within the Revit model. So that's a good quick little exercise of taking information from the Revit model, manipulating it a little bit in Grasshopper, and then pushing it back into Revit. So for the second example here, I want to use some family components. So in this case, what I'm doing is creating some columns, and I'm just going to go into some open space out into the courtyard here. I'll maybe create a little Stonehenge out in the green space. And what I have here is some internalized geometry. Now for this example, I want to snap this over, and I actually want to open up my Rhino window. Looks like I have some leftover objects. Okay, so this is my Rhino window, and again, this is full Rhino 7 running as a plugin within Revit because it's using Revit's model space. So it's a very powerful tool here. So I'll just go ahead and snap this over, and I'll just zoom in to see what I have here. So this is my internalized geometry here. Well, I guess that's shown down here. Let me turn that off. So I've got this internalized geometry that I've fed into this script, and this is all just Grasshopper components. In the end, it's just going to be this this rectangular column that I've created here, and then with the Rhino.Inside.Revit components, what I can do is create a new component family. And as inputs, what it needs is a Revit family template. So what I've done here is just specify a file path where to find this specific Revit family template. It should be pretty much the same on by default on every machine. This is just the family templates folder installed with Revit 2021, which if you've just installed Revit 2021, you'll need to install those content libraries separately, just a little note. But we're giving this component, new component family, the template file. I'm going to set override family to true. I have named each one of these objects column rotunda, and then I am making sure that it's being created on the column category. So here we go. I could go ahead and activate or enable this component, and it should now create all of these families from that that column that was existing within Grasshopper. So if I zoom out here, I can actually see these created in the Rhino model space, but I can also see them within the Revit model space as well, because it's created these columns here. So that's a nice little feature there to create from any sort of Rhino geometry. You can then create these families based on a family template. Now, something that I can do instead of just having this simple rectangular column is make some modifications within the Rhino model space. So what I'll do here is, let me bring my Rhino window back, snap it over here. Okay, and let's go back to this origin. What I'm going to do is just bake this so that it exists as geometry in the Rhino model space. It is now a Rhino object. And then what I can do is select that, and then with this geometry component, I can set that one geometry. So this Grasshopper component is now referencing what I have in the Rhino model space. I'm going to go ahead and hide that. So now I'm going to switch this internalized geometry to this geometry that I'm referencing from the Rhino model space. And then that's going to update everything accordingly. Whoop. And just give it a quick moment here. I get another. There we go. Okay, let me just go back here and just make sure that this is, I'm just going to disable that temporarily. But with this geometry here, what I can do is modify this within the Rhino model space. So let's say I take this vertex, make some changes there. Maybe I'll take an edge here, move it slightly, just make some strange modifications to that. That will then update here because it's referencing that geometry that's in the Rhino model space. And now if I go back up here and activate this component, it should update based on what was changed within the Rhino model space, and it will update that every instance of that family that's been created within the Revit model. So as you can see, I've got all these now shown in the Rhino model space, and same down here. Now I could create a live link here between these, just for performance sake and for because time is a factor. I'll just leave that as it is there. But now, in addition to making these types of changes, oops, I forgot to mention this part of the definition. My apologies. So what I did here was just create a single instance, and then through this component, which was the add family instance by location, I was able to distribute all of those points across this grid. So I could easily now change this to, instead of a rectangular array here, I can change it to a circular array, which is defined by these Grasshopper components here. So if I just toggle this, this stream filter from true to false, it should update the locations of each one of those family instances so that they now appear within a circle that I've defined with my Grasshopper script here. So there we go. It's now updated. It's deleted the instances that were previously created in the rectangular array and recreated them in the circular array there. So you can get a sense for the flexibility of creating new families, locating family instances and location and wherever you decide based on different parametric conditions within the Grasshopper script. Okay, so that's a good example of how to use families and create new families based on templates. Now I want to go into adaptive components here. Now, this is probably going to be the last workflow example that I go through here, and I'm just going to lock the solver first before opening this one up, just in case. Okay, so I'm just going to run through some of what is happening in this script. It's a little more involved, but not too much. There's still just a few things happening at the end with Rhino inside Revit to create that bridge between Grasshopper and Revit and really make this happen. So what I've done here is just create I've got a polygon here, and let me just activate or unlock the solver. So I have a polygon. In this case, it is a 6-sided polygon, and I'm feeding that into one of these new components, the quad remesh, which is within the mesh tab in Grasshopper for Rhino 7. And what that does is subdivide this closed planar curve into a series of quads, which four-sided curves. And then with those four-sided curves, I'm going to apply some physical forces to them to create a space frame. And then with those quads, I'll be able to feed in those 4 points, because the quad has 4 sides, 4 vertices. I will feed those 4 points into an adaptive component that has 4 adaptive points. And this can be applied to adaptive components of however many adaptive points. It just requires that they match up so that you're feeding in the number that that component requires. So I'll just snap this off to the side here, and let me just show you what I'm working with here. So I've got the polygon, and there it shows right there on the lawn. Let me just get rid of some of these columns here, and just something to note. Everything that is created through Rhino inside Revit, when you create a family instance or a direct shape, comes in pinned, so you would need to unpin it in order to delete it. But it is something that's it's very helpful to just keep everything that's created right where it should be. So here I've got my 6-sided polygon, my hexagon, and then I've run the quad remesh. I'll activate this to show the boundaries there. So here you can see how that has subdivided. And I'll go back to Grasshopper here. And all of this is being fed into a Grasshopper definition, which will simulate the physical forces applied. The physical forces were defined right in here, basically deconstructing each one of those quads, turning every line segment into a string and into a spring rather, and then applying a lifting force to all of the segments or points that do not lie along the perimeter of this hexagon. So let me just confirm that I've got this one. Yep, that is not enabled. So I'm just going to enable my kangaroo here and then do a little reset. Now, as you can see, it's modified slightly here because it's run through one iteration of that simulation, but I will turn that off. And if I click play on this trigger here, it'll allow the simulation to run. And what you saw there was the simulation running 10 times per second. So I can just reset this just to show you how that works. And I can also go back here, and while that is running, I can change the forces that are being applied to this. So this is just one example of some of the very powerful tools that are available with Grasshopper. So once I have this to an equilibrium, it is converged to a nice state here. I can now take this geometry, which is still set up as a series of quads. They're no longer planar, but they still have 4 sides and 4 vertices. So I will deconstruct these, extract all the points, and then feed all those points into my Rhino.Inside.Revit component here. So what I have here is I'm defining that I want the adaptive component to be a curtain panel. I've already pre-created this and loaded it into this host drawing, so that's something that you would need to do as well. In this case, I just have it as an adaptive component with a frame but no panel. And so if I go ahead and activate this now, it should take in all of those series of points that are grouped into 4s and create new instances of the adaptive component, which is poorly named adaptive component, no panel, but it should finish up here in a second. And then once each of these instances are created, we can then start changing parameters to modify this each one of these instances in a unique way. So in this case, my Grasshopper definition is analyzing the points for each quad and then determining the orientation of that plane. And based on the orientation, if it's more horizontal of a panel, then the thickness of the thickness of the frame will be much larger. So the opening where the panel would be, if it did have a panel, is much smaller. But if the adaptive component is oriented more vertically, then it'll be more open. The frame will be lighter, and yeah. So you'll be able to see that, and by creating the adaptive component with these parameters of and to be clear, they'll need to be instance parameters. By creating that beforehand, I'll be able to then modify them after I create them through Rhino.Inside.Revit. And I can also do that with material parameters. I can create a material parameter and assign that to an object within an adaptive component family, and then modify that parameter at a later time. Looks like maybe my computer is having a little bit of a tough time. It could be due to just all of the things I have going on in this drawing. But I can just quickly flip over to another example that is it's very similar. It's using those same type of adaptive components, and in this case, I'm using the Microsol Resources logo here as the driving image, the driving geometry that is that I've brought into the Grasshopper canvas here. This is the image sampler. So what can be done is some sort of boundary detection. So I can find the boundary here, create, do the quad remesh and everything the same that I did with the hexagon, but then apply, because I have colors that I can associate to materials here, I'm able to extract the RGB values, and then in some of these components down here, I'm able to drive the material parameters for these adaptive components. So first I'll just, let me just do a little, need to reorient this here. Let me just select one of these. So I'm rotating about one of those. So as you can see, this is sort of what I had mentioned, where these adaptive components are a little more horizontal, so they're more their parameter is such that it results in an almost completely closed adaptive component. Those panels that are oriented a little more vertically have a larger panel in a smaller frame. So that's how that was determined there. Let me go back into the Grasshopper window here and show you how some of these Rhino.Inside.Revit components are changing the appearance. So what I have here is some of these material components from Rhino.Inside.Revit. I'm querying the materials from the Revit model. I'm taking the RGB values from the image that I brought in through the image sampler. I'm creating new appearance assets. I'm duplicating some of the glass material that is in the Revit model. And then with this component, this is the replace material assets. I'm then able to change the material assets to the appearance that corresponds to the color as it shows within the image. And then let's see here, through the set element parameter, I'm able to redefine each one of those parameters. So in this case, the name of the material parameter that I've created within the adaptive component family is glass mat, and then the new parameter value are all of the new Revit materials that I've created solely through Rhino.Inside.Revit. So that's a neat way to control both materials and sizing of these adaptive components. Now, if I wanted to change this from blue to something a little more festive for this time of year, it's a little more Thanksgiving, pumpkin pie. Everybody's got that on the mind, so maybe change the colors to something like that, or we can even change it to something with a little more gradient. Now this results in way more materials being created, but because of this workflow within Grasshopper, it's able to, and all of these wonderful Rhino.Inside.Revit components, it's able to juggle all of these things all at once. So this one is going to take just a little bit more time in order to apply these materials, but it should be finished up quickly here. And sometimes there'll be some need to I'm thinking back to my math background of decision levels. So in analog to digital conversion, the analog signal is on a continuous spectrum, but you need to basically snap it or round certain values to discrete values. In this case, we may want to determine a fewer number of colors that are possible so that fabrication costs are not so large, or something like that. And that can be applied to materials, it can be applied to dimensions. But as you can see, a lot of flexibility to make these types of modifications there. So that's a nice looking deal there, and all just really driven through these images. These are PNG files, so you can just imagine what is your sketchpad, where do you go to get your inspiration? And you can find that, try and extract the information or data in some way, feed it into this flow, and then use that as a generative tool. So you can use images, we've seen sound being used, run a Fourier transform on an audio signal, and then convert it into quantified values that can then drive some generative components here. So here I can switch back here, And as you can see, with this hexagon, this nice structure has been created. And that, again, that was through the add adaptive component here. And then afterwards, the panel thickness was modified. So the more horizontal panels were would be closed up. All right, so that's I think that kind of covers the simpler examples of how the adaptive components can be used within Rhino inside Revit, in addition to creating and modifying material parameters. So it's certainly a powerful tool, and I think it, more than just a tool in and of itself, I think it has a lot of benefits of allowing generative designers to enter into this process, either if they were exclusively in Rhino and Grasshopper, you can now enter into these Revit-based projects, or if you're solely in Revit and you're looking to do more than what you can in Revit or with Dynamo, then this is a possible alternative. So, okay, with that, I'll just switch it back to the presentation, and I just want to flash some of these resources in front of you here, and I can copy these into the chat box, but you can take a look at our website, microsolresources.com. We sell Rhino, Revit, all things Autodesk, and so if you're interested in Rhino 7, feel free to contact us. Otherwise, you can go right through the Rhino 3D/buy webpage to purchase Rhino 7. Additionally, there are a lot of resources here. There's the I'll just open this directly here. Oop. I must have made that whole thing a link. My apologies. So yeah, I'll copy this, all of these links a little bit later. But there's, if you're new to Grasshopper, there's some nice videos on Vimeo by the creator of Grasshopper, David Rutten, and there's also the McNeel forums that are very useful. Anytime somebody's having an issue, everybody at McNeel is very quick to help out. The buildingcoder.typepad.com, Jeremy Tamek's blog, is very useful for understanding a little bit more about the Revit API and how Rhino inside Revit can make use and connect to that API to extract valuable model information. There's also foodforrhino.com, which I flashed in front of you. That's where all of the great plugins are for Rhino and Grasshopper. There's also Grasshopper 3D on YouTube. You can follow them, and many other Rhino tutorials on Vimeo. So feel free to check out all of those resources. And I think from here, we're about ready to open it up to questions. And yeah, I hope that was helpful.
Thank you so much, Joseph. We have a lot of questions to go through, and I know we promised you will be done within the hour, but for those that are interested in hanging in there, trying to find out and asking more questions, feel free to do so. I believe we'll have more time beyond 1 o'clock. Joseph, I also wanted to ask Scott and also Ehsan to turn on their video right now so we can ask questions. One of them, I'm just going to just jump right in. As I mentioned, there's loads of questions. One of them came from, is it Terje or Terje? Sorry. But he said that he cannot install Rhino into Revit, and he got an error message, error 200. He tried to fix it through a workaround of the site, but he's not able to. And Scott, would you be able, I think you answered this, but could you send the link, or is that Ehsan?
Yeah, well,
in the chat box. Yeah.
Yeah. So that's the forum. So I think that went to Oh, no, that didn't go to everybody here. Let's do this. So there's a couple ways. So we always have our forum, which is there, that you can ask questions, especially when these get difficult. And then let me show you I will also send a link directly to the -200 error. And what you're seeing there is a conflict between Rhino and another Revit plugin. And we're slowly tracking these down and trying to fix these. And so you can go to that article and give it a try. You can also go to the forum. So those are the two pieces there that should be able to help you. You know, if you can't get it fixed, make sure to get on a forum, and Ehsan and I will be there to try to help. Annalisa, you seem to be muted.
Sorry. Yes. One of the questions earlier on was, you know, somebody else had Rhino 6, and when Rhino 7 coming out, does the beta still work, or the work in progress, or is that no longer working? And do they need to upgrade?
Yes. So the beta currently works probably for another 30 days. And then you have a choice. You can upgrade to Rhino 7, which is available today to upgrade to, or you can download the demo, the evaluation version, which will give you an additional 90 days to work. And then you need to update at some point in time from 6 to 7.
Sounds great. Thank you. And I'm just putting in a link where they can do that, and also probably let you know that if you have any questions or need additional help, I should have done this earlier, which is basically make sure you can send an email to rhino@microsolresources.com for any questions that we didn't cover today. Having said that, I think it's a question either for Ehsan or for Scott. Will Rhino imported geometry inside Revit ever become editable once it's living within Revit, or would it have to be edited within Rhino?
It really depends. So the answer is yes. It just depends on how you transfer it. So if you transfer it as a family form, then what you do is it will be editable, like by stretching it in Revit. If you do it as an actual native object, let's say a floor plate or an adaptive component, and it's completely editable, just like a native Revit object would be in the first place. So it just depends on how you transfer it, which components you use. You know, Joseph showed different ones there and is very familiar with, you know, what can be edited and what can't. So.
Sounds great. Thank you. And then a question from Alejandro, or is it Alexandro? Sorry. Would Revit materials be transferred when transferring geometry from Revit to Rhino?
They can be.
And for use in visualization?
Yep,
okay.
They can be. So you can use Grasshopper to transfer or materials one way or the other, out of Revit into Rhino or out of Rhino into Revit. And in fact, if you use something like V-Ray Next, you can actually use Grasshopper then to create materials from the Revit materials and the Rhino materials and the V-Ray materials, and they all work together. And that's a very new set of components that we have in Rhino.Inside.Revit just in the last build.
That's great. And in fact, actually, we've had an iteration of our webinar in the past wherein Scott and Joseph, I know we've done one wherein we did the workflow from Rhino to Revit, and then V-Ray for Rhino, which is KuScript is a partner of Microsol Resources again. And if there's an interest on the others that are here, we'd be happy to do another webinar for that. If you are interested, let us know. We'll be happy to send you an email. Just send an email to marketing@microsolresources.com, and myself and Miriam will invite you once we have a date for the next one. Okay, we have a lot of people that are very excited about the new tools, the new features. One of them, I think it's Mark, is like asking, is he able to use Grasshopper with Revit, especially, okay, so we did say yes to that. Oh, and then he wanted to find out, can he use the energy tools, Honeybee and Ladybug, within the workflow as well?
Yeah, so Honeybee and Ladybug running in Grasshopper, running in Revit will work. And you can grab the Revit geometry if you want. You can grab the Revit parameters if you want, and use those in the Ladybug and Honeybee workflow. And in fact, the results you can store back on the Revit objects if you'd like, all with Grasshopper.
Fantastic. Okay, maybe that's another workflow we can use for the next event we're hosting too. Yeah. We can talk to Muhammad, and I believe
there's one question on here that none of us are willing to answer. Only Joseph can answer.
Which
is Joseph gonna let these samples out for other people to download?
Oh, yeah. I certainly can. I would be happy to. Yeah,
so
maybe somebody I think was interested in the file.
Together and, Oh, okay.
Yeah. That just answered like 10 questions right there. So thanks. That was good.
Maybe not with the Microsol Resources logo, but maybe the hexagon will be fine.
Understand. Did you have other questions you wanted answered this on, or Scott?
No, I was trying really hard to stay on top of all these questions that are coming. There's a lot of great questions in there. I see a lot of questions related to the work that's coming in the future. We are working on a key piece of technology that's we call it the element binding. That allows us to record information about the elements that Rhino.Inside.Revit generates inside the Revit model. So when you open the Revit model later, if your teammate opens it with Grasshopper and stuff like that, it will be able to pick up what he has created. This is a key component, and we need to be able to add all the create components later. They let us create curtain walls and all the other sort of like native Revit elements and types and stuff like that. So we're hoping that we'll soon go to the version 1 with this element binding technology in, and then after that we can super quickly add other components to deal with drawing sheets and all the other most important Revit types that we generally deal with. So that's one. And then there's a lot of questions between direct shapes and elements. A lot of people are wondering sort of like the extensibility of the editing capabilities in Revit, which Scott already answered to. But just to reiterate, direct shapes are generic containers that can hold any type of geometry. Revit doesn't need to understand how that geometry is being generated. It's not generated from any metadata. It just gives you a container that you can throw stuff in it. Native elements, they don't care about the geometry. They care about the metadata. So Revit wants to know what's the structure of the wall, the properties of the wall, so it can generate the geometry for you. The Grasshopper, the Rhino.Inside.Revit, will provide you components that you work with these native Revit elements. So you can create native Revit elements, and after the creation is done, as far as Revit cares, there's no difference between that element being created manually or from Rhino.Inside.Revit or from any other Revit add-on. So you have full editing capabilities of Revit at your hand with this kind of elements. I don't know if you're saying any other question, we can talk about that as well.
There's one there. Yeah.
There's one. There have been a couple that talk about the BIM 360. So BIM 360 is a hosting platform. If you open your BIM 360 model inside the Revit environment, you can continue working with Grasshopper Rhino.Inside.Revit with it. As far as Rhino.Inside.Revit cares, it's just a Revit document, and you can then synchronize it with BIM 360. Whereas you can put and use the Rhino.Inside.Revit capabilities over the Autodesk Forge using the Forge Design API and stuff like that. That needs to be tested and figured out in the future to see if we can install this on the you can install this on the cloud and sort of use these features and stuff to batch process Revit models. Sorry, Scott, go ahead.
No, let's go ahead. That's great. Yeah, and please, as people have more and more questions, make sure to get up on our forum and we can work through some of these. Some of these questions are quite, the answers are quite complicated. So come on up to our forum and we can help everybody out as much as possible. In fact, there's too many. There's so many questions up here. I can't even read them all. It's the first time ever for a webinar.
That's what I was
I'm
going to
way
say.
behind.
It's 1:05 right now. Yeah, and then I want to give some time to all the questions that are coming in here, and obviously we might have to have a hard stop at some point. But before we even do, Ehsan, Scott, and Joseph, do you have a few more minutes to stay behind? And should we maybe like take these questions up until 1:15? Are you able to do that?
Yeah, whichever works. So should
Yeah,
I
another 10
just
minutes?
continue
Okay.
answering? Should I just continue
Fantastic,
answering
yes.
the Q&A, or you want to answer through the video?
No, let's ask this on the video. So somebody came
Okay.
asking, she's working on a civil project that results in large objects, over 100 feet long, and they want to find out if when they're not using Revit, they're using civil, or they are using Revit. So they just wanted to find out, are they able to test this particular workflow and projects like that are more civil or infrastructure based?
Yeah. The Rhino-Inside.Revit doesn't really care about the sort of like the extent of the model that's dealing with. They're just to the program. They're just numbers. And Rhino itself has templates for sort of like models based on different unit systems and different resolutions. So you can set up a nice Revit model for yourself, a Rhino model for yourself that's more appropriate in resolution for civil projects and stuff. And then you can continue working with Rhino inside Revit to bring all that geometry into Revit and vice versa.
And in addition, Rhino has connection, Grasshopper has connection to Tekla and has a connection to Sophistic. And so if you wanted to, for instance, get the geometry out of Revit and into Tekla for precast, or you wanted to go out of Revit into Sophistic to do analysis of the reinforcement, that's been done a lot lately, just with all these new connections of inside, Rhino inside, lots of different things. So from a bridge point of view specifically, there's a lot of different options.
Is that available for Civil 3D? Oh, sorry.
No, you go.
Not Civil 3D specifically. We can, we can read some of the information, and we can do topology and things like that. But when it gets to the concrete and the steel and those structural pieces, that we're going to go off into other places with that.
Annalisa, I'm going to add one more thing. There's a lot of questions and comments about, hey, can we do this? Can we do that? And sort of like asking, inspecting to see what's possible with Rhino inside Revit. Me and Scott are both architects in background, I guess. Scott, throughout the years, has a lot of experience working with structural engineers, MEP engineers, and stuff like that. But for a lot of very specific workflows that are related to structural or MEP kind of design paradigms and stuff like that, we might not be the best people to actually make the decision on how the component should work. So we very heavily rely on the feedback from the users. As Scott mentioned, it'd be great if people can join the Rhino Inside Revit forum and ask, like, if you want to see more rebar components, come to the forum, post what you need, show us like how exactly do you want this to work and stuff like that, and we'll get it implemented and tested.